So far in this unit, we have talked about factoring, and we have talked a little bit about graphing. And today we're going to tie those together and look into a little bit more about how graphs and the functions fit together. So one thing is, when we've talked about this, that when you graph, you have to know what the intercepts are. And the intercepts are, the x-intercepts are, they come from the factors. So we have to factor these. So on each of these problems, when we start out, we are going to start out by factoring them. And we have lots of different methods, so you just have to be able to look at them and decide which way to factor. In this case, I'm looking at what I have here, and I think that a negative 2x squared is going to be my GCF. And if I factor that out, I'm left with an x squared minus 1. It's a minus 1 because I factored out a negative 2x squared, and a negative times a negative is a positive. And we learned that that is not quite finished. I have one more step, so my factored form is going to be negative 2x squared, and then I have to factor this down to x plus 1, x minus 1. And so these factors are what are going to give me my zeros, or my x-intercepts. So this first factor is going to give me an x-intercept of 0, 0, and the other two are going to give me x-intercepts of 1, 0 and negative 1, 0. Now, also, when we think about graphing, we think about the end behavior. And the other day when we were doing the Graphing with Desmos project, at the bottom of that we came up with a little summary of how each of these should work. So what I do for this is I look at my power, and it is a fourth power, so it's a quartic. That is even, and it has a minus in front of it, and so I know it's going to be upside down, and so I know it's going to look like this in some shape or form. Now these two bumps, they might be totally asymmetrical. They don't have to be symmetrical, but it's going to have a general shape like this. In other words, my end behavior goes to negative infinity on the left-hand side, and it also goes to negative infinity on the right-hand side. I will also warn you that this page, the formatting got messed up when I went to print it, so some of these lines are a little bit off. All right, now that we have all of that information, we want to go to our graph and start graphing. So I'm just going to make a couple of tick marks here. And also, I'm going to tell you that you'll notice that the y-axis isn't very long. That's because in a lot of ways, I don't really care how high or how low it goes in a lot of ways, because a lot of these are going to go to like negative 295. And we're not going to have a piece of graph paper big enough to go to negative 295. And so we're just going to give some general shapes, some general idea of how these are going to look. Okay, I have my graph a little bit set up. I need my intercepts on here. So I have a negative 1, I have a 0, and I have a positive 1. And I know it's supposed to look something kind of like this. And so I'm going to go ahead and draw my graph in here. It's going to look something like this. Later on in the next page, I'm going to tell you a little bit about some more clues from this. But at this point, all you need to know is these are the x-intercepts, this is the end behavior, and so our general graph is going to follow this curve. All right, let's take a look at number 2. Again, you'll notice that we need to factor this. There is a GCF, so I can factor out a GCF of x. And now I have this trinomial, which I'm assuming is factorable, because otherwise I don't really know how to plot that. So those are all prime numbers, so I should be able to factor that by the guess and check method. If you prefer the box method, you can do the box method. If you prefer the splitting the middle term, you can do splitting the middle term. But I know that this is a prime 3, so it has to be 3 and 1. This is a prime 1, so it has to be 1 and 1. The only difference is that we've got to figure out our plus and minus signs. It is a minus 2, so that's going to be a minus there, and that's going to be a plus there. Okay, that is my factored form, so I'm going to write that in this spot here. Now that I have it in factored form, that's going to tell me my intercepts. So 0, 0 is an intercept from this. Negative 1/3 comes from this factor, and positive 1 comes from this factor. So this time I'm going to go make my hash marks. I'm going to kind of spread them out a little bit more just so I have space to get that 1/3 in there. because I have a 0, 0, I have a negative 1/3, and I have a positive 1. Once again, the x-axis, the y-axis is purposely left kind of short because I don't really care how high or how low it goes in general. All right, let's talk about end behavior. It is a third degree, and it is positive. A third degree positive is going to look something like this. It's going up from left to right, it goes up. And so this on the left-hand side goes to negative infinity. On the right-hand side goes to positive infinity. So I can now go to my graph. I can follow this basic pattern of my end behavior, and I can just go, the graph is going to look something like this. I don't have specifics. And again, if you went to your graphing calculator and put that in there, this might go way down. Too far for us to see. So we'll get to graphing calculators in a little bit. But in any case, I have my x-intercepts. They are plotted here. The y-intercept actually I also have. It's a 0, 0 as well. And I know my end behavior, and so I'm able to graph it from there. Okay, number 3. Why don't you pause the video here, take a look at number 3, try to factor it. Once you factor it, find out what the zeros are, and then come back and we'll talk about some of the other things. Okay, when you graph it, you should come up with x times x minus 3 quantity squared. Again, this does factor down to x minus 3 quantity squared. That means my zeros are 0, 0, and 3, 0. I plot those points on my graph, and here are my intercepts. And my end behavior, once again, it is a cubic, and it is positive, so it's going to look something like this. And again, these two bumps, they could be way down here. They can have a variety of looks, but it's generally this shape, which means that on the left-hand side, it goes to negative infinity, and on the right-hand side, it goes to positive infinity. Okay, I have my zeros, I have my end behavior, so the graph on number 3 is going to go from the bottom on the left, from the bottom, going up, coming back down, and going up again. Number 4, I'm looking at number 4 and I'm seeing a quartic. So this is a 4th degree, it is positive, it's going to look something like this. The end behaviors are both going to be positive. We need to factor it and figure out what those zeros are so that we can make a graph. So again, why don't you pause the video here, see what you can do for factoring so we can graph it. Okay, once we factor out the GCF of x squared, we have this trinomial left over, that is x minus 4x plus 3. So we know what our zeros, our intercepts are. We know what the general shape looks like. So it's going to look something like this on our graph. And once again, these two bumps do not have to be symmetrical. One of them might go way down, but I'm not concerned at this point. I'm not concerned with how far down it goes. Number 5, as I look at number 5, I know I have to factor it, but I'm seeing a 4-term polynomial. So I'm going to have to do factoring by grouping. So why don't you, again, take a minute, see if you know how to factor this by grouping. Okay, so when we factor it by grouping, we get x squared minus 4 times x plus 3, but x squared minus 4 does factor down to x plus 2, x minus 2, and then again we still have our x plus 3 here. So we have our zeros at negative 2, positive 2, and negative 3. And also, this is the first time that we've had an x-intercept other than 0, 0. We know that the way to find the x-intercept is plug in the way to find the y-intercept is to plug in zeros for x. And so if we do that, we get a y-intercept of 0, negative 12. That's not asked for here on these notes, but actually on the worksheet, we're going to be needing to find that. And sometimes that's also just a helpful little kind of an anchor of where, how far down to go. We have all the information that we need. We also need to talk about end behavior. It was a 3rd degree cubic. It is positive, so it's going to go something like this again. That means that this left-hand side goes to negative infinity. The right-hand side goes to positive infinity. And so when I graph this, it's going to look something like that. And I kind of skipped my point there, but you get the idea. Okay, I cleaned it up a bit. There is the graph going again, following this basic shape of my end behavior, starting down at the left, coming up, going through, hits -12 and goes through there. So that is the graph. Number 6 is a little bit different because we have been working on graphing. And number 6 actually cannot be graphed. Excuse me. Number 6 is a little bit different because we've been working on factoring. Number 6 actually cannot be factored. If we talk about end behavior, we know that the end behavior, we know is going to be a parabola. It's going to look something like this. But it cannot be factored. End behavior, we know, is positive infinity on both sides. Factored form, well, it doesn't factor, so we can't do that. But we can find the zeros. How do we find the zeros if we can't factor it? Well, the only way to do that is to buy the quadratic formula. Take a second now to pause the video, do the quadratic formula, and see what you come up with. Okay, here I did the quadratic formula. That comes down to 1 plus or minus the square root of 193 over 12, or as a decimal, 1.24 and -1.07. So the intercepts are going to look something like this. I also know that my y-intercept is -8 because of that -8 there. And I could find the vertex. I'm not actually asked to find the vertex. -b over 2a is what it would be. But all I need to do is plot this. So when I plot my graph, I didn't do a very good job. It's not supposed to have a little wobble in here, but my axes are off and whatever. But the important things that we are focusing on today is end behavior, we got that. X-intercepts, we got that. And also the y-intercept does play a part. So that is part of it. So the reason I included this example is there might be times when you cannot factor it. If you cannot factor it, in order to find the zeros, you might have to do the quadratic formula. Okay, at the beginning of this example, of this page, on our first example, I said I would talk to you a little bit about some specifics here. Because what I want you to do now is look at this page. And as you look at this page, I want you to find anywhere you have an x squared in your factor. So number 1 has an x squared. Number 3 has an x squared. Number 4 has an x squared. And that's it. So 1, 3, and 4. If we look at 1, 3, and 4, and at that term, which is the x squared term. And so number 1 has an x squared. That gave us this 0, 0. Here's my 0, 0. Okay, so then if we look at number 3, we have this 3 is squared, which gives us the what's going on here. And then number 4, the x is squared, which is the 0, 0, which on our graph gives us this at this point. What do you notice about each of those that I've highlighted in yellow? You should be noticing that it's kind of like a bounce. I call that a bounce. So in other words, like we look at number 4. It's coming down here, it goes through -3, it comes up, bounces off, and comes back down, and comes up through +4. The reason it is bouncing like that is because it is squared. And so the squared actually gives us 2 answers, like x is 0 and x is 0. And what happens when we do that is we have a bounce. Turn the page and we'll talk about what this is called and why this is happening. This is called multiplicity. And anytime you have a power on your factors, that is called multiplicity. So this 3, that has a multiplicity of 3. This has a multiplicity of 2. That tells us the behavior at that place. And so if we read through here, it says if it has multiplicity, an even multiplicity, then it doesn't cross it. It touches it, but it does not cross it. And that's what I call a bounce. So an even, I call that a bounce. Then, if it has odd multiplicity, it bends as it crosses over. So they have an example here. Here they have an even multiplicity at 3, and they have an odd multiplicity at 0. It bounces off and then bends through there. That's called multiplicity. So in other words, if we look at this example, the third power, now it's not the number inside, it's the power. The third power is going to give us a bend. The second power is going to give us a bounce. And then there's not a multiplicity here, so it's just going to be a normal, I'm going to call that through, just a normal crossing through, okay? So in other words, if we look at the graph of this is going to be a little bit difficult for me to draw, but I'll do my best. We have 3, 4, 5, 6. So it is a sixth power, and it is positive. Sixth power and positive looks something like this, but some of these bumps can kind of be combined, just to throw you off. So it's going to look something like this, but it might look more like this, or it might just look like this. So anyway, something along these lines of both, the end behavior is both positive. So what's going to happen is, this is going to start on the left, starting at the top. It's going to come down. Now, I'm at -2. What should I do at -2? Well, at -2, I should go through it. I'm going to go through it. I'm going to turn back around because I'm supposed to hit this, so I have to turn around. So I'm going to turn around, but I'm supposed to bounce off of that one. So I'm going to come up, and I'm going to bounce off, and I'm going to come back. Now, it was supposed to touch that, so it's going to go up like that. It's going to bounce off of it. Going to come back. And then at -4, or at +4, it's a third power. It's supposed to do a bend. Let me show you what my bend is supposed to look like. It's supposed to look something like this. Almost like an S, sort of, but it's just very, you've seen them before when we've done some of our graphing, but it's just a really gentle bend like that. So this graph is going to look something like this. This is a very rough draft, but it does have the intercepts, it does have the end behavior, and it has the bounces and the bends that it's supposed to have. We'll do some more of those so you'll see some examples. The rational root theorem is written out here. You should read through this. What it basically says is to find the roots, the rational roots. Remember, rational means like whole numbers or fractions. To find the rational roots of any polynomial, what you do is you take the coefficient, that is just the numbers of the last term and the first term, and you list them all out. The last term goes over the first term. In other words, my last term here, which they talk about in terms of P's and Q's. So this is my P and this is my Q. So what I have is, they're all positive and negative, so I needed to include all the positives and negatives. It could be 25/1, or it could be 25/2. Because of this 2, the factors of 2 are just 1 and 2. But the factors of 25 are 25 or 5, so it could be 5/1, or it could be 5/2. 1 is also a factor of 25, so it could be plus and minus 1/1 or plus and minus 1/2. All of those numbers are the possible roots of this polynomial. Now, that looks like a pretty long list, except if you think about all the possibilities from infinity, at least we've narrowed it down from there. So this allows us to narrow down if we don't know how to factor it, because I'm looking at this problem and it has 5 terms and it is a 4th degree, and we haven't talked about how to factor a 5-term 4th degree. So how am I going to graph it? Well, this will tell us how to at least start looking at the graph. We'll talk about this a little bit more tomorrow, but this list is a list that gives you a starting point so you can start to see where should I even graph it from. And what this allows you to do is it allows you to go to your calculator and kind of zoom in and find out, is one of these that are on the list, is one of those also in your graphing calculator? In fact, let's go ahead and go to the graphing calculator. Get your graphing calculator, plug this into your graphing calculator, and I want you to use your graphing calculator on this rather than Desmos, because this is the kind of thing where maybe on a test or quiz you would need your graphing calculator. So you need to know how to use that graphing calculator. Get out your graphing calculator and just put this polynomial into your graphing calculator. And then when you've got it into the y equals, go to Zoom Standard and see what you have. Okay, so here we have the graph, and it's cut off, so we could zoom out if we needed to, but really we don't need to. Really what we're looking for is these places, are they actually places where we hit the graph? Because that sure looks like a -1. Well, -1 was on my list. That looks like a +1, and then I'm not sure, maybe 2.5. So -1, +1, maybe a 2.5, and then 1, 2, 3, 4, 5. That sure looks like a 5. So the numbers that we have, let's go back to our paper, and it looks like from our graph that we had a -1, a +1, a +2.5, and a +5. So those should be my x-intercepts. Well, how would I know for sure? Well, what we have to do now is we have to do synthetic division with those and see if they work. I'm actually going to come over here on the right-hand side because I need to have some space vertically to do this work. So I'm going to start off with my first one, which is a -1. So I'm going to set up my synthetic division, and I'm going to see, does -1 actually work? Because on the graph, it sure looked like it did, but I need to see if it actually does. And so I need to prove it. And to prove it, I need to do the math to do that. So I'm going to do my synthetic division. So I do my synthetic division with a -1, and it does go in because I have a 0 remainder. Okay, so -1 does work. Good. The other one that looked like it did was a +1. I'm going to go back to my graph just to double check that one. That one I'm not sure about. Yeah, +1 looks like it does go in. So I'm going to do synthetic division, but I'm going to do it from here. Because just like if you think about, I don't know, like the number 24. All right, does 2 go in? Well, yes, it does. So if you divided 2 out, would 3 go in? Well, you don't have to go back to 24. You can go back down to 12 where you are. So basically, I'm going to see if 1 goes in, but not from the top. I'm going to do it from here. So I'm going to bring down my 2, and I'm going to do my synthetic division. And sure enough, 1 does go in, 0 remainder. So I'm going to go to the next one, 2.5. Actually, you know what? I'm just going to do 5 because it's a whole number. It's just going to be a little bit easier. So I'm going to do 5 at this point. All right, I went ahead and changed colors because it was getting scrunched in there. So yes, 5 does go in. So I came out with a remainder of 0, so that's right. And this thing that is left over, I could try it with the 2.5, but I actually know, remember we talked about, what power is all of these? And if this is the remainder, this is the linear, or excuse me, this is the constant term, this is the linear term. So this is actually 2x minus 5. And so that, if I solve that, wouldn't it give me 2.5? I indeed don't know how to factor this because it's 5 terms. We haven't factored 5 terms, but I just figured out from my division what those 5 terms are, those 5 factors are. So my factors are x plus 1, x minus 1, x minus 5, and 2x minus 5. That is my factored form. And so now if I graphed it, I have the information I need to graph it. Okay, the main point of this page was not all of that business with the graphing and the division, all that, although we need that. So I wanted to do that example because we will need that. The main thing is this long list. Are you able to generate this long list? And the way you do it is the factors of the last term over the factors of the first term.